Hello, hello, hello. Good morning, good evening, wherever you are. My name is Mark Borstein. I'm the CTO at Tremolo Security and the co-author of Kubernetes and Enterprise Guide, third edition. My co-author and host, Scott, will be joining us. He's running a little bit late. Yeah, we've got an interesting one this week. So we're on the last chapter. We're on chapter 19. And what's really big about this chapter is that we take a lot of what we've learned in the past 18 chapters and said, okay, let's build a platform, right? Because the thing is, Kelsey Hightower said this, right? Kubernetes is a platform for building platforms. You don't deploy Kubernetes just to deploy Kubernetes. You deploy Kubernetes in order to build something on top of it. And that's what a lot of the success of Kubernetes has come out of, right? Because if you go back to previous attempts at different types of platforms as a service, they all tend to fall down once you get too constrained. So, like as an example, you start looking at things like Google App Engine, not to pick on it, but all these different types of platforms as a service, and you get to a point where there's just there's too many constraints, right? You're making some assumptions, and that's good, but those assumptions have to line up with your organization. Every organization is different, and so that's what has, I feel, really led to a lot of Kubernetes success is the fact that you can build a platform that works for you, right? It works for your enterprise. I'll say that a lot of times the you'll deploy platforms, you'll find that you need to make adjustments, but because every organization is different, you have different software, you have different implementations, you have different needs, you have different developers, you have different regions, you have different regulations. A one size fits all approach never works, right? And so, in the last 18 chapters, we've talked about how do you get users into your cluster? How do you add storage? How do you do logging? How do you how do you get APIs to talk to each other? How do you do monitoring? How do you do policies? So we looked at all these different things, and now we're going to start building out um, a final platform that shows, hey, this is an example of what you can build. Now, the point here, it looks like we got Scott. Hey, new phone, who dis?
Hey, see everybody. Well, good to see you, Mark. Good to see anybody out there that's listening.
Yeah, so we were just or when I say we, I mean me, was talking about chapter 19 and building out this platform and just, one of the things that makes Kubernetes so different about past platforms is the ability to build a platform that works for you, right? Rather than building a platform that makes assumptions based on what other people think is the right way to do things.
Mhm.
Um, and that's a really big deal because in the year of our Lord 2025, you've got a lot of different, every company does things, every enterprise does things different software builds, and you're rarely coming into things greenfield, right? Like um, you generally have uh, some kind of existing, Git repository, some kind of existing workflow management, right? Like there's a million different um, things that you're already running, and so coming into things, you know, when you want to build your Kubernetes platform, you're not starting with a complete greenfield. You've got to work in an existing environment, which means you got to know how these different pieces fit. Um,
Mhm.
and so that's what we do at chapter 19 is we take a lot of the things we learned, not all of them, but a lot of the things we learned, and we build out a platform. And I'm going to go ahead and share a page from the book. Where are we? So this is the platform that we're going to build out. We got a lot going on here. We've got a control plane that's going to orchestrate everything. That's where we're going to run our secrets management. We're going to use Harbor, which is open source, an open source OCI registry that is put out by VMware, and hopefully, as you're watching this, it's still put out by VMware.
It is now. Who knows?
Is Quay open source?
I thought it was. Yes.
Yeah, I don't remember why I did Harbor and not Quay when we first started looking at, but Quay's another option. Quay is from Red Hat, formerly CoreOS. It's Red Hat. It's got to be open source if it's Red Hat. We're going to use Argo CD for GitOps, and we haven't really talked a lot about GitOps. We're going to talk a little bit about that. You know, we'll probably spend almost an entire day or an entire chapter on GitOps. We're going to use GitLab, and GitLab's going to do a couple of really important functions. It's going to be our Git repository. It's going to be our workflow engine. Previous editions of the book, in the second and the first edition, we were using Tecton. Decided to move off of Tecton because it's really lost a lot of steam, I think, since it got launched. Tecton is the build system for Knative. And so when serverless or functions as a service, whatever you want to call it, became super popular 3-4 years ago, or more than that, I guess. I mean, we're talking 2019, 2020. One of the first CNCF Kubernetes-based serverless or function as a service projects was a project called Knative. And Knative used a very, I would say probably heavy approach for going from code to running container, where it would kick off a pipeline that would build your container, that would launch it. And that used Tecton. Then Tecton was eventually broken out into its own thing. And it's still used, I believe, in OpenShift. I think that's the underlying build system if you use OpenShift's built-in pipelines. In the 3 world, it was Jenkins. And then when they moved to 4, I think they replaced Jenkins with Tecton.
Yeah, I'm trying to remember. I know they have Argo CD.
I know they have Argo CD in there, but I'm pretty sure that Tecton is the pipeline technology for OpenShift these days, for the OpenShift 4 platform at least. So we originally had Tecton, and we removed it for this edition to simplify it. And GitLab has its own built-in workflow system, so we said, okay, we're just going to use that, make our lives simpler. And then, of course, we're going to use Open Unison to orchestrate everything. And then we're going to have a development cluster and a production cluster. And so what will be important about those is when we onboard new tenants, you'll get a development namespace in the development cluster. You'll get a production namespace in the production cluster. But you're also going to get a vCluster in each. So it's not just namespace as a service. You're getting a virtual cluster as a service. And so tying back into what we did in chapter 7, chapter 8, whichever chapter it was, the vCluster chapter. We're going to automate the rollout of vClusters. Both the development cluster and the production cluster will have its own MySQL, which means they'll have to have its own local storage, right? And then, so when I onboard a new application team, that new team is going to include a development cluster, a production cluster, vClusters, repos inside of GitLab. We're going to make sure that GitLab is able to talk to the various clusters to be able to run workflows and whatnot. Argo will be set up in a multi-tenant way so that I, as a user, will only have access to to my applications. Harbor will also be set up in a multi-tenant way so that I only have access to my images. And then finally, we'll have Vault set up. So we're integrating a lot of what we've done over the last, over the last 18 chapters, 17 chapters. We're not doing everything. At one point, I said, we're going to include OPA in this, and we did last year in the second edition. This edition just got too much. This chapter in particular, I think, took me about 4 months to write. The other major difference between this chapter and previous chapters is we're going to use something called infrastructure as code to deploy. So in previous chapters, we did everything via bash scripts, right? Bash all the way down. This time we're going to use Paloma, and ran into a lot of challenges. I'm not going to lie. I've got a lot of thoughts on IAC and their impact on the costs and the pain of deploying infrastructure, but we'll get into that. So obviously, with all of this infrastructure that we're going to run, it's a little big for a kind cluster, don't you think? I mean, that might be. Yeah, the eyebrows.
Yeah. It's not that you couldn't do something, but man, it would be pretty complex to pull off.
Yeah. So, plus, you wouldn't do that in anything that even kind of looks like production. Like you wouldn't run your dev and your prod in the same cluster, right? And so in previous iterations of this chapter, what we did in the first and the second edition was we ran everything in one giant cluster. It was like, just throw as much memory at this kind cluster as you can. And we'll just put everything in there. And that didn't feel realistic. Even from a learning how to develop stuff standpoint. So that gives us what we're going to build to. And so the next question is, how do we build this? Like, where do we start? Now, in the book, we say, you should really have like 8 gigs of memory for each of these servers, dedicated to workloads. That's a lot of hardware and horsepower, right? I mean, it's only until maybe a year or two ago that even like your standard your standard this is an XPS 13 maxed out at 16 gig of memory, right? Like I think it's only within the last couple of years that your standard laptops are starting to come with 32 or 64 gig of memory as an option. So what do we deploy this to? Right. And so that's a long way to get to the fact that we're talking about home labs. What does a home lab look like? What does your home lab look like, Scott?
Wow. Franken lab, but that's okay. I use a lot of SBCs, as you know, Mark, right? So
And
single board
SBC is
computers.
single board computer.
Yeah. I mean, you can call Pi that, right? They do because it's all there, but they have
Yep.
Intel, right? And some of these Intels even go up to a i5 kind of processor, and they just stay really small and power draw, and I can get 64 gigs in them. It
Really?
uses SO DIMMs. Yes, I have 232.
Which single board computer are you using?
I got a couple. I'll have to pull up all those names. The recent one though, I really like. I got to pull it up again, but they have a new version. It's an i3. What's nice about that is you obviously getting all your hyper-threaded cores, everything else with that, far
Right.
more than you get with like the Intels that you see a lot, like the N platforms.
Yeah.
which are still okay. You get quad on those, but no hyperthread, and they're just a little bit slower. But I haven't seen either go past 64 yet.
What do
So
those run on price?
um, so if you got the Intel N series, they were like $160.
Yeah, they're expensive.
Not horrible at 160 in my opinion, but yeah, because you get a Raspberry Pi 4 and you start dumping in the, 1632s,
Yeah.
they start getting up there in price.
Yeah, that's true.
But these have your NVMe, slots in them, which can be converted to a PCI slot. I do that for a GPU,
That makes sense.
and most have two in them. So you can do one for your actual NVMe, or actually, I have one that has four NVMe
Hmm.
slots. It actually converts one to four. And then, ironically, this where'd it go to? Where'd I do? Oh, this just came in for me because I had to get a new laptop. So it's a new Asus.
A new
Um,
Ace?
yeah,
Okay.
it looks like a Surface Pro in a way, but you see how thick it is. But this thing has
Oh,
128 gigs
yeah.
of RAM in it.
Wow. Nice.
It's the AMD. It's the 395 AI Max chip, so 16 cores. This is a monster.
That is a monster. And that
Um,
is that got a Surface style cover for a
it does.
screen?
Yeah, so the keyboard, it looks just like a Surface.
Interesting.
It's about 2 pounds. Came in yesterday because I wanted to upgrade for my 3D stuff. But so 128 gigs, I need at least 64 for my 3D.
Ah,
But 128, I can run some pretty beefy VM labs off this thing.
yeah. Yeah, you can. And bonjour, Kafka.
Azure.
Thank you as always for being. I definitely think Kafka wins our most loyal viewer and joiner to the
I'll
show.
click on
So
it. Yep, yep. With Boris
um,
out there too
yeah,
as
yeah.
a second.
Um,
So
that
yeah,
that that
yeah.
is
I
interesting.
think when we get into that
That's
conversation, Mark, there's a lot we can get into.
well, and like, yeah, I'm going to show off a couple of pieces of the. So this used to be my data center in a box. So when I used to go
Okay.
to shows for Tremel before before the pandemic, um, these were Udu boards. So these are Intel based boards. Now
Oh,
these have got to be a decade old at least. Um,
mhm.
where I want to say these are cell runs.
Oh yeah, I remember those when they were a popular board for a while.
Yeah, and they had 4 gig of RAM. These are all dead. I had a flood in the house, and these all got soaked. And I don't even think these will boot anymore, to be honest. But this was great for a long time for me because I would run Windows on this one for Active Directory, and then I do. There was actually another one on top, so I do a API control plane and then 3 worker nodes and show it off. And then I had the router and everything set up. Um, you know, you see guys like this all the time available on Amazon. This is also a cell run. I got this a few years ago. I think for like 120 bucks on Prime Day. This does not have enough horsepower to run this lab. To be honest, this I think has 8 gig of memory in it. I was using this for Metal as a Service controller for a long time. But what's good about these is while they're a little more expensive um, than just single board computers, they do run fanless, low power chips, so you get lower draw on energy.
Yeah,
Um,
this is actually one of the boards that
oh,
it's
nice.
had, and underneath you'll see that there's the
Yep.
two SODIMMs and NVMe. Yeah, really small when you think about what this can run.
Yeah. And you've got just a normal heat sink on there. It's fanless.
Yeah, yeah. If you put a fan on it, you can actually do overclocking on it, but no reason to
Yeah.
in this. So, and it
And
has SATA slots as well, if you wanted to use those. I was pretty impressed by them. Again, I'm trying to keep the draw down.
yeah, that's the thing is it's the power draw that really it gets expensive. Um, and I
Being
think
idle,
Kafka,
yeah.
Yeah, and I think Kafka is really hitting on the point that where I'm going to land on this is a PC with a lot of RAM goes a long way for a lab. Like having a bunch of these things or a bunch of those looks really, really cool. But to get the most bang for your buck, just buy a PC.
That's why I
Um,
like the 64 gigs on this, because two of these, you got a pretty good setup with 128 total.
yeah, exactly. That gets you a lot of horsepower. I will tell you, like, I don't, let's see, can you see it? See if we can show off my office here a little bit. Uh, so that's my two main home lab servers. So I consolidated everything down to two servers. They're beefy. I mean, one of them has I think 196 gig. The other has 128 gig of memory. They're both one's a Xeon, the other's an i9. Actually, no, I think those are both i9s with NVMe's. Um, this one, I've almost completely rebuilt. I had an issue with Proxmox, and we'll talk about VMs here in a second,
Mhm.
where it couldn't talk to storage anymore, the local NVMe. I was like, oh, I guess the NVMe drive died. That's bad. So I swapped out. I pulled out the NVMe. I dropped it into nifty things that you can do. So like, let me see. Do I have it in here? I've got a. Oh, I know what I did with it. It's up here. So you can take an NVMe drive, and they have these adapters. They can just plug it into USB,
Oh, yep.
right? Like this is the simplest one. Um, uh,
Yeah, I
I
live off
actually
of
just got
those.
a nicer one that's a little easier to work with. So I took this, plugged it into one of my Linux laptops, and like it's like, no, all the data's there. You're fine, dog. I'm like, huh. Well, I'm just gonna back it up just in case. So I backed it up. I moved it on to another, but all my VMs were there, right? Like it just all the volumes that Proxmox created were there. Um, so then I was like, okay, well, the drive seems okay. I'll replace the drive. Replace the drive. Same problem. I couldn't even reinstall Proxmox. I had completely jacked up my Proxmox on that server, so I was going to have to reinstall it anyway. And I'm like, okay, memory, maybe, maybe the memory is the problem. So I ran memtest overnight. Everything was beautiful. I'm like, oh, okay. And I was having issues talking to USB drives. I was like, I guess it's a bus. Like a bus on the motherboard? But I've never had that problem before, but okay. So I replaced the motherboard. Same problem. I'm like, is it the CPU? Because I've never had a CPU, and that CPU is less than 2 years old. I have never had that happen. And sure, so I replaced the CPU and everything worked. So this is almost an entirely rebuilt server. The only thing that's original in here is the memory.
Wow.
Um,
Yeah, trouble,
yeah,
process of elimination. The only way to
process.
get through
Yeah.
that.
Um, so, but the thing is this one's got, I think, 32 CPUs. This one's got 24. Like, that's a ton of horsepower. And that's more horsepower than anybody's mostly going to need. I use it because, like, I generate lots and lots of clusters. Like, I need to test a feature, I fire up a single node cluster, right?
Yep.
I've got customers whose cluster, that I run development clusters that I run on there. So I run a lot of stuff. I've got Windows VMs and stuff. Um, but and Kafka is 100% right here. I love Proxmox. I started off. I had a lab that used. We talk about this in the book. Metal as a Service from Canonical, which was originally designed to uh, originally designed for bare metal to be able to onboard bare metal in a cloud native kind of way,
Mhm.
um, and added support for Clemens. So you were able to add VM servers basically. Um, and it worked really well for the most part. But the thing is, if you wanted to use anything but Ubuntu, you were kind of hosed. Um, so you could use Windows VMs, but you wouldn't get this nice web UI for managing everything. So I wanted to go to a project based on KVert. I'm a Kubernetes guy. I like KVert, but it wasn't ready to really go. And then finally, I looked at Proxmox. And I actually had originally thought Proxmox was just for LXC, which is a different kind of container type. But I ended up realizing that for any, it does VMs too. And I absolutely love it. I'm a paid open source license customer. Um, they're great. It's a great product. It gives you the ability to have a lot of the enterprise features that you would expect from a VMware, you know, but at a home lab capability. So like I've got two servers, and if I need to move a VM, they'll just go, right? They'll talk to each other. They don't have to have shared networking or shared storage the way you do with like uh, um, if you're just running vanilla libvirt or QEMU or KVM, those parts of technology. Um, it's great. And so what I ended up deciding though for us for this is I took one of my older towers. You can kind of see it down here. This thing, older tower. I want to say this thing is 12 years old. It's older than my oldest son, and he's 10. Um, I want to say this is a 12-year-old box. It might even be older. This might have been the first large tower I bought for Tremolo. And so it's got 64 gig of RAM and 16 threads. So a little less than what I'm recommending, because if we stayed with the recommendation, it would be closer to 32 threads. But I think we'll be okay. We'll make do. So we're going to go ahead and deploy the Chapter 19 lab onto this. And I think the way that we're going to approach this is, we're going to kind of work backwards. So I think what we'll do is today we're going to deploy the Linux control plane using Talos, like just the cluster, like none of the stuff we talked about before. Then next week is KubeCon, so we won't have a show next week. I'll be in Atlanta for KubeCon. If you're in Atlanta and KubeCon, you see me, you see say hi, say hello, please. Love running into folks. And if you are watching and you're going to be in Atlanta and you don't have a copy of the book, our friends at vCluster are going to be giving out copies on Tuesday. Check their social media. Or no, Wednesday. I think it's Wednesday lunchtime. And I'll be there signing those copies. So you get to come by and say hello. Scott, unfortunately, will not be joining.
Touchy subject.
Party pooper.
I know it, no doubt. Originally, it was partly because I might have been in India next week for work, but not going to be.
Oh, did they cancel that on you?
So far, rescheduling.
Okay.
Stuff, right? Things just couldn't time because getting a visa.
Right?
Yeah. I never even considered adding the time of, that always takes a couple of weeks regardless.
Yep.
So,
yep.
Kind of good. I think it's been possibly for January. We'll wait and see.
I think I gotta move this over.
That means I could have maybe gone.
But
too late now. Too late.
Yeah, too late now. But so anywho, now we need what are we going to choose as our Kubernetes, right? I would not. Oh, and one last thing about hardware. Buy used if you want. Like this stuff's expensive, and people tend to go through a lot of it. I was looking on eBay, and you can get a PowerEdge server, a tower server basically for like $600, $500. Um, don't go crazy. You don't have to spend ungodly amounts of money to build an effective lab. And look around for used stuff on eBay. If you are blessed as I am, excuse me, to have a micro center near you, Micro Center has a great website to help you build a custom PC where it takes a lot of the guesswork out, and like you can these were both from Micro Center, parts from Micro Center. In fact, so is that one.
And I wouldn't call this out all the time, Mark, but the Reddit has a decent home lab, subreddit. It's
Yeah.
good group. You don't see a lot of the trolling there. You just get, you might get some people that are kind of.
Well, it wouldn't be
short.
Reddit if there wasn't trolling.
There's be something, but a little bit less there because it's not a vendor versus vendor thing, and
Yeah.
but you do get some decent people that'll, even the builds and how they suggest it.
Yeah.
And sending out their, the bill of materials essentially to say, hey, here's what I've done. I know a popular one, I think kind of like what Kafka's saying here too, is the mini PCs, right? There's not probably a week that goes by that I don't see an announcement of something coming out, something like this AI Max chip, because it's running a Radeon. You can actually allocate up to 64 gigs of RAM for my video card, and I can dump the LLM completely into RAM, so it never has to even try to read.
Right.
I don't know how often I'll do that, but it is kind of nice, right? You're not going to get a 64 gig video card.
No.
Most of the time. So that's where you do this. That's why I kind of like hem and hawed between 64 and 128 when I got the model, but the 128 was $400 more. And
the memory is expensive.
Yeah.
Memory is probably the most expensive.
But when you get to these, they're soldered, of course.
Yeah.
Thickness, so I'm like, I can't just upgrade. Servers, typically 60% of your cost is RAM.
Yeah.
Right.
I mean, I will say, I was just going through and pricing out on Micro Center. Go ahead and show this up. At stage, there we go. I was pricing out on Micro Center. Where'd it go? I was on another thing. I was pricing on Micro Center just to be able to say how much it'll cost, and I typically go with an integrated for servers. I like to use integrated graphics. I don't want to be messing around with.
Power first of all too when you're going external. I mean, why bother?
Yeah.
Yeah.
Now, if you're going to do some LLM testing, that's a whole other thing. I've gotten it working with Kubernetes. It's a little bit. We'll show it off in a future show, but it's fun in the way that it's fun to have your fingernails ripped out with pliers.
Kafka's got a good point here. With the mini PC, he says here, and you're right, because people talk about Thunderbolt, right, as well for the external GPU.
Yeah.
But Oculink is the way to go. Just it's faster.
Yeah.
You do it how it draws the frames and that's actually what I do with. We'll give you a real geek one, Mark. Nobody wants this for their home lab, but that's an Asus Ally.
Oh, you got one of the Ally.
Yeah, this is the before Xbox one. So this is the Ally X, but it's a huge Radeon AMD. This has 32 gigs in it, which does work well. I mean, you Oculink to this, kind of like what Kafka was saying. You've got a gaming PC, but I was running Kubernetes on this because there's enough RAM at 32 to do something. But this is becoming a popular thing for people now because you can travel with it and just kind of put a screen on it. So you got your little gaming console with you, and you can do other things. It's
amazing. My game that size, except it barely played 8-bit video games.
I know it's crazy what you can do with this thing. 'Cause this thing can emulate up to a PS3.
Whew.
I mean, it's just you get on and just play with emulators, or and of course any Windows in that.
Yeah. Um, so yeah, so there's a lot of options for hardware.
Yeah.
Don't go to a cloud provider, please. All you're doing is burning money. Like it cloud providers, even their free tier, you can't build this in a free tier. I was originally doing this with a smaller cloud provider, and I was spending like 200 or 300 bucks a month on 3 clusters. Um, and I eventually moved. I had a weird networking issue with my old MAS cluster, where if I used VirtIO as my network card, the clusters couldn't talk to each other on 443 or 6443.
Hmm.
It was the weirdest thing ever. But if I changed it to use Realtek as the emulated network card, everything worked fine. Very weird. I never figured out why. Um, but once I figured that out, I started doing it on in my network. But so I put Proxmox on this box down here, and yeah, like I said, we've got 16 CPUs. I've got 64 gigs of RAM. One thing I'll also say is if you've got a PC that you've bought and it's got an old 5400 or even 7200 RPM drive, the cheapest way to give it a speed upgrade is drop an SSD in there. Like over, you will see. I put an SSD in this thing, and it ran like a brand new system. Like there was no, like it was night and day. Let's see what those. What's Kafka asking? So, do you recommend? I mean, I I would avoid any of the cloud providers. If you are going to go with the cloud provider, go with the cheapest. I do like DigitalOcean because they're easy to get up and running. One of the things you're going to run into with this lab when it comes to any of the cloud is, and we're gonna tackle this at the very end today. Uh, we're an enterprise book. In any enterprise, you're going to be using a custom CA for your certificates. You will not be allowed to use a something like a Let's Encrypt or whatever. So that means that because our harbor is going to be sitting behind our ingress controller, which means it's going to have RCA because everything is self-contained, your clusters have to trust that CA to pull the images down. And so a lot of the cheaper, the less expensive cloud providers, if you go with if you go with their Kubernetes, you can't upload certificates. So that'll make this lab impossible. However, if you wanted to say go with like a droplet and install Kubernetes and then do it that way, that's certainly an option. Like if you want to use kubeadm, like that's how I originally built this. Was I did it with kubeadm. We're going to use Talos, however, and I've almost completely gotten rid of kubeadm. I don't deploy kubeadm for anything. I do everything with Talos Linux these days. I don't know if you can do Talos in DigitalOcean. Um, I know you can do Talos in AWS. They have an AMI or an AMI, whatever they call it. I don't know if you can do it with DigitalOcean. It'd be an interesting one to look up. But if you are going to do it with a cloud provider, then you're probably going to want to end up doing it on VMs rather than their native Kubernetes implementation. But it's a good question. So how we're going to deploy this.
DigitalOcean does, according to what I'm looking at, quick, Mark.
Oh, it does do Talos? Excellent.
Yeah, I see creating a Talos Linux cluster on DigitalOcean via the CLI. So
Beautiful. So yeah, so that would definitely be a option. Okay. So the next trick will be actually, let's get this thing up and running. So I've actually got a script, and I'll post it as a comment, that lets me bootstrap a Talos cluster, gets it up and running, installs Nginx, and installs local storage on it. So that's what we're going to do for our lab. So I've got Proxmox in here. This took me about 10 minutes to get up and running once I download the ISO and flashed a USB drive. It is insanely easy to get up and running. You don't have to worry about building bridges or bonds or any, like it just sets all that up for you automatically. So I'm going to go ahead and let's create a new VM. Create a VM. And we're going to call this control plane. And I've already gotten the ISO image from Talos. So you know the Talos image factory. This is just a standard image. There's nothing crazy about this. You can get different add-ons, iSCSI, and all sorts of different stuff. That's not necessary for this because it's all on-prem. And we're going to leave that as a default. And I'm going to give me 100 gig. The space isn't at a premium. Now I want 8 gigs, so I'm going to do a 2x4, so 2 sockets, 4 cores. And I will tell you, I always do host pass-through, without emulation to the CPU. I run into all sorts of weird problems, like MySQL will not work sometimes with some of the emulated CPUs. So I always go with host.
I would agree with that anyways, Mark. I see no reason not to. Normally,
Yeah.
so.
And I'm excellent at math, so let me do some. So we need 16,384. Now the control plane needs the most horsepower because it's going to be running everything except for your application. So that's going to be important to have a lot of horsepower. So networking. So all right. So that created our VM. There it is. And let's go ahead and fire it up. So Talos, the great thing about Talos is it's a Linux, it's a Kubernetes. I actually don't know why they call it Talos Linux. I feel like they should just call it Talos Kubernetes, but not my company. So it boots up, and we're not using Omni, which is their management platform. We're doing everything open source. We don't want you to have to sign up for anything. Not that we don't love Omni, it's a great system. Just we don't want you to have to sign up for anything. But you could totally do this with Omni. So you'll see that it starts up. We have a dynamic IP. The system's not really ready to go. It's just like, okay, what do you want me to do now? So we're going to go ahead and going to F3 over, and we're going to call this cp.tremolo LAN. 192.168.2.1, 192.168.1, and we're going to use the built-in interface. We're not going to use DHCP. So it had already given us an IP of 170. So I'm just going to hijack it. Right. So I'm giving it static. Now, in theory, you wouldn't really need to do this in the real world because you have things like load balancers and um, uh, something like speakers and whatnot. But for my development purposes, just having a single node cluster with a static IP is easiest. So I now have a static. I now have a Talos cluster with a configured static IP. So I'm going to run my script. So I'm going to come up here and deploy. Now, I'd already run this earlier with 170. See here. So how's that look? No. There we go. Okay, so you can see that. So I'm going to go ahead and I'm going to run deploy Talos. So this is going to take a few minutes. And what's happening is we're bootstrapping the cluster. We're getting standard configurations. We're updating the machine config so that way it knows where our hard disks are, and make sure that that all works. And then we are going to deploy a single node cluster. So I'm going to tweak the config so that it knows to schedule workloads on the control plane node. You typically, when you deploy Kubernetes, the control plane nodes are marked as unschedulable. They're still nodes. They're just, you can't schedule to them. And so that would let you go ahead and this will give you everything. Now, in theory, because Proxmox has a RESTful API, my original hope was to skip the part of manually putting in IP address information. And I wasn't able to do that. And actually, I think, no, this is a little bit different. We'll talk about that in a second. There's a weird quirk in libvirt where a VM, so in order to tell, if you don't have Pixie set up, and I don't have Pixie booting for DHCP set up, in order to get Talos static IP information, you have to do it as kernel parameters, except you can't use kernel parameters with libvirt when booting from an ISO. Really weird combination. If I had spent more time on it, I probably could have eventually figured it out, but it became counterproductive at that point. So what I ended up finally doing was saying, screw it, I'll set up my own networking, and then this script will get me up and running. So Kafka's got a question here. Have I ever built Proxmox cluster inside of a single host via nested virtualization? Not a Proxmox cluster. What I have done is use, so one of these boxes runs a Fedora system that's got libvirt running on it so that I can run a OpenShift dev cluster using pass-through virtualization. So that I've done. But I've not tried multiple layers with Proxmox. But I'm sure it would work fine, to be honest. But it's a good question. Okay, so we have our cluster. And if we come back here, we'll see that we've got 52 processes running. It's got a host. Everything looks pretty good, right? And then I'm going to go ahead, come back here, and let's take a look at Kubernetes. Yes. cp.talos.lan, kubeconfig, kget node. So I got my that, kget pods all. So I've got my ingress controller running, right? So if I come back over here, I go to https x.192.168.2.170.nip.io, and we're good, right? Like we've got there's nothing there, obviously. We've got Nginx. I've got that running, and I also have local path provisioner running. So that gives me the ability to create local storage without having to manually set things aside. So we've been using local path provisioner throughout the book. So this has it working with Talos, right? Now the fun thing about Talos is that's different is that you notice like we didn't deploy all Linux, right? Like we didn't first install Ubuntu and like it's all integrated, it's all one thing. The tricky part about that is there's no way to install anything. You've got to install everything either through their image factory if you want to add additional libraries, so things like iSCSI, stuff like that, and like it's both, you have daemon sets that will run within the nodes to install stuff. So that becomes really interesting, especially with storage. You often get custom binaries. Or log management, you'll get custom binaries, but there's no SSH. I can't SSH into this. I couldn't if I wanted. There is no SSH, which is great because that's one of the things lock down. That's one of the things secure. It does often make things a little interesting when we're talking about add-ons to your cluster outside of stuff. But we've got our base cluster. The only other thing we really need to do is, like I was talking about certificates, how do we get a certificate in there in order to trust it? Right? That's where things get interesting. So I've got Talos's documentation here. And what Talos says to do is we're going to create this trusted root. We'll make this custom trusted roots config. Add our lab CA certificate. And then we'll go ahead and patch the environment. So I'm just going to grab this. So come back here. So I'm going to create a new file. And that's custom CA. And let me grab in the chapter 19. There's a file called labca.pen. This is the certificate authority for our lab. So let's go ahead and paste that in. And because of YAML, make sure everything lines up. Line up. Oh, that looks good.
Yeah, because it looks like it lines up there.
All right, let's try this. Because sometimes all right, well, if it doesn't work, then we'll know. So, all right, so I'm going to come back here. I want to go to CP. We'll call this custom CA. Oh, okay. The ID, I think, got confused. It was interpreted as something other than YAML. So we have our trusted root config. So now I'm just going to be lazy. And in the right directory? No. d.tremolo.land. So this is the command I ran earlier. 170. 170. So I've got I'm going to patch the machine configuration with my custom CA YAML. And yeah, so let's see, this should just work. Patched and configuration without reboot. So now if I had a multi-node cluster, that would, I'd have to run this across all the nodes, which is a good reason why you would want to use something like a Omni to help manage it. This is so much easier than when I used to have to like I had a Ansible playbook that I had for deploying these single node clusters, and man, it was brutal. Something would change because like when it worked great before they switched from Docker to um, Containers D, and they got rid of the Docker shim because I could just install Docker and use the Docker tools, and then that went away for Container D. And Container D doesn't use, I think it's Toml it uses, which is really a pain in the butt for its configuration. So that
Yep.
was fun to try and automate. And it was such a pain. And you just saw how quickly I was able to just get up and I this is so easy for me, Scott. I don't even use our custom uh the from chapter 2. I don't even use that anymore.
I tend to use a lot of our scripts past that for
Yeah.
deploying the stuff. I usually modify them a little bit too.
And the other nice thing about Talos is if you've got a Docker instance running, like Mac, I got Docker desktop, whatnot. You can run Talos like kind, where it runs inside of a Docker container. It's got a lot of the same limitations as kind. Now, I don't think we would ever want to we get to the 4th edition. I don't think we would want to swap out kind if for no other reason than being able to go in and make low-level configuration changes in a way that's not vendor specific, because everything you do at Talos is very vendor specific because it's Talos. Like they don't have everything's with their API. So I don't know that I would ever want to go away from kind unless kind just stopped being kind.
Worse, they're adding some new cool stuff into kind because even doing the registry
really?
is becoming easier to do something local.
Nice.
I was trying to do that on my one laptop because I'll be on a plane undoubtedly trying to just play because I'm traveling and be like, damn it, I can't pull the image.
Yeah.
So I'm working on that, but it might be something we do for the book. We just include it, but yeah, and stuff like if you're using an LSM, like a Linux security module, right? It's different than this because it's not SE Linux, it's not AppArmor.
Right.
So certain things don't work
Yeah.
quite as well. I know the AppArmor is looking at that. They might have already addressed it. Mark,
Okay.
I brought this up to them already at one point and said, yeah, what about Talos? And because it is gaining a lot of traction.
Yeah.
And one thing I know you're not showing here is some of the automation they even include, right? Because they've got their UI.
Yeah. That's the Omni piece. Yep.
Oh, that is the Omni. Yeah.
Yeah. And they just had support for OIDC, which is really cool. Cool. But yeah, I've moved all of my development workflows over to Talos. I don't do anything on kubeadm anymore. It's too easy to get up and running and use. I'm not going to go through and build the other 2 clusters because nobody needs to watch the paint dry on my UI. But I'm going to go ahead and set those up, and in 2 weeks we'll come back and we'll start rolling it out. And my guess is we're probably going to spend a good 4 or 5 weeks in this chapter because there's just so much going on. And in fact, if we do, assuming we do a 4th edition, we'll probably break this up into some chapters. So yeah, that's all I got. Scott, any parting thoughts?
No, this is it's a great chapter in general, right? So I agree, and going through it all, and we'll find out how I'll be because I got my surgery coming up, but I'll still be able to get on a call. I just won't be able to type.
Well, hopefully it's a nice, easy surgery.
It's my tendon here is torn off the bone, so they got to reattach it. It's not
Well,
totally torn. It's close, but it causes massive pain, and
I can imagine.
I have
Yeah,
to keep my arm straight for 2 weeks once they do it. I'm not looking forward to that. Also,
that's
not
not
looking
going to be
forward
fun.
to, I will be awake during the surgery. That's always a great thing you want to hear.
You have to be awake.
Yeah, they'll put you in la la land, as they say, but no general
Ooh.
anesthetic. So, gotta say, I'm not looking forward to the thought
Well,
process.
I
But
actually have had that before, and they might like they might
you-
as well have
you're
no
heavily
remember
out of it.
anything. You're completely at like once the drugs kick in,
Yeah,
like you're wee, and
I'll still have
you
an
have
IV,
zero
so it's
memory.
just not the typical
Yeah,
general anesthetic. So yeah, I know I'll be fine. Plus, frankly, it hurts so much, Mark. I don't care.
yeah,
Like, just go
exactly.
fix the thing, and
And
I'll be happy.
you gotta think about your baseball career here. I mean, you might be out for a season, but you know, when you come back.
I'm sure that's
Um,
part of what did it was my old baseball career.
All right. Well, so again, if you're a KubeCon, if you're watching this before KubeCon NA 2025, and you want to say hello, come find me, or come by, get a free copy of the book. To Lofts, or actually no, they're V Cluster now. They've completely, I think technically the name of the company is still Loft, but they've rebranded the V Cluster. Um, and if not, we'll see you in a couple of weeks to start rolling stuff out. Talk about infrastructure as code. So thank you, everybody. Thank you, Scott. And if you haven't had a moment to review us on Amazon, please, please, please. Makes a big difference, huge difference. Um, Enjoy the rest of your days.
Thanks, everybody. And if everybody going to KubeCon, enjoy.